There's Chuko the cat welcoming everyone to the stream. This was where the cat was hanging out. There we are. Yeah, so getting back to a stream after a bit of a slow week, I ended up legit coming down with an entire cold, not just like, you know, when you're getting started with coming down with a cold, you kind of hope, oh, I hope this is just a small one. But it usually isn't. It's usually an actual cold. So that happened. Now we've got a cat. All right. So, this is going to be a continuation on the voltage glitching project. Wow, we're getting a lot of flickering on that video channel. I wonder what's up with that. There's like some kind of bad cable in here that I'm going to replace in the near future. Alright, see if that fixes it. I think I just need to re-terminate one of these little bits of coax on this camera rig, but I also have the project to build an entire other camera rig for Tuco, so I could see not worrying so much about this one. Oh, nice to see familiar faces in chat. Hello, Alfie, and hello, Wildmania. Anyway, so today I'm getting back to the voltage glitching project. So I had a bit of a cold this week and ended up not getting as much done as I hoped. But on the bright side, I did have a chance to run the glitching experiment for a while and just like let it go and see how that works. Which I have done before in a similar setup with this, you know, not this particular PLC, but the other one before I bricked it. I got a little bit of results back, you know, nothing especially great, like no firmware dumps, but I did at least get a couple of interesting glitch events where it looked like I had disrupted some kind of templating engine that the web server was using. So I got back a copy of the index.html with some of the variables not substituted in. But so far, this glitching run doesn't seem to have given us too much yet. Let's get this playing back. So this is running at 4096x real time. So I think this was like 60 hours of experiment footage I got this week, mostly while I was with the cold and just babysitting it every so often. So you can see the scope trace down here kind of shows what's going on. The red trace here is power. In this case, we have a pretty sensitive amplifier, just amplifying the AC components of the processor's 1.8 volt core rail. So here you can see this pattern is kind of a main loop where the processor, you know, runs one iteration of the interpreted program that the PLC has. You know, it kind of, I can imagine that being a sequence of different operations that, you know, maybe have different memory access patterns or talk to different peripherals, and so they cause a distinctive pattern in the CPU's power usage. So you can see that line up with this other signal down here in D2, which is a debug signal I added in the interpreted PLC program that just toggles every iteration. So this is kind of a time reference for where the main loop iterations are happening. So then this D3 is the kind of synthesized trigger signal that the FPGA generates from these other signals, indicating when to start timing the glitch event. So that goes to the chip whisperer, then the chip whisperer inserts this glitch into the power through some other signals that aren't on the scope here. And then these two events, we're inserting them in between. This is the HTTP packet coming in from the experiment, and then here's the HTTP response going out. So this is the window where somewhere in between here, it's going to be interpreting this request and figuring out what to send back, and it'll be responsible for filling in a structure with the addresses of the chunk of data that it plans to send back. And if we can glitch that code in just the right location, we can get that to send back some other portion of memory, like hopefully some firmware. So This is something that I've gotten to work to the point of giving me back a 64 kilobyte clean dump of the larger firmware image. So not a full firmware dump, but I got that 64K dump on a previous version of this experiment using using the same CPU but with known firmware. So we're still trying to get the first actual firmware dump from this device with unknown firmware. And the last time I ran this experiment, I got some glitches with some kind of interesting results, like that one that I mentioned that failed to substitute the variables correctly, and some that just seemed to be corrupted in different ways. This time, though, the red indicates just a failed response, which aren't super interesting. That can happen for a number of reasons. And then the white ones here are normal. And so, even going through the results, none of them were abnormal in any interesting ways. This was totally a failed experiment. And there could be a number of reasons for that. These are the same hardware glitch parameters that I was using before successfully. So while there could be something wrong with the actual glitch shape, it seems more likely that perhaps I was just really unlucky with the offsets this time around. So my goal for the next experiment here is to just basically do the same thing, but try to make it run much faster so that I can just test more offsets. Because this was still not testing the space super exhaustively. I think here each one of these glitches was about 15 clock cycles long, and I was stepping them by 10 or maybe 20 clock cycles. So that still isn't really enough to, just given how much randomness is involved here, that isn't really enough to exhaustively test this space by any means. So, and even that took like 60 hours to run. So the real bottleneck here is just that for every experiment, I'm resetting the PLC, and that takes, like 7.5 seconds. It's very slow. And that's largely because I've underclocked it so much. And then, just noticed Philip in chat saying that he was impressed at how full my water glass is. I did just refill it. I guess I should drink some more of that. Still kind of getting over the cold in case I sound weirder than usual. So yeah, there were a number of things going wrong with this experiment. You can kind of tell that the timing isn't really dead on, just based on how much this is kind of wiggling around. So let me skip ahead to the part where I was triggering the scope on... So you can see some of these I was triggering the scope on these later signals, and some I was triggering the scope earlier. So these later signals, these are always correct. Like this signal on D4, that always happens right after the interesting data processing I'm interested in occurs. The reason I don't use this as a trigger, it's super reliable, but it just happens too late. But I can use that to trigger the scope still, and then investigate how steady the earlier triggers that I kind of heuristically create ended up being. So if we get back to that again. Yeah, so the signal on D3 is our heuristic trigger. So this location I have the mouse on is usually where it shows up, but you see quite a few triggers where it shows up one cycle early. So that's not so good. That could definitely be cleaned up. That's not so bad because it basically just means that every time we do an experiment, there's a random chance that we actually end up subtracting a roughly fixed amount from the offset, or like adding a roughly fixed amount. So you end up with this pattern where, so if you look really carefully at this red region, you can see this sort of spike move along slowly, and that's our glitch that we're inserting and sweeping along. But you can also see there's kind of a shadow over here where sometimes we end up hitting the glitch at kind of a fixed offset, basically one full main loop iteration before when we should be hitting it. So it doesn't broaden our search space quite as much as if we were just, inserting something totally random. It just gives us an extra decision point there that we don't really want. So, that's something I could clean up, not as high priority. Really, I think the most important thing here is just making it not have to reset the PLC for every single experiment, but be able to reset it if there's a problem. There's also this issue where sometimes you might see that it just gets stuck entirely and returns all red until I come over and fuss with it, like here. And that's when the As best I've been able to narrow that down, that is something happening that requires sending a hardware reset to the peer microcontroller I have running the Ethernet proxy. So like this board over here needs to be reset. I tried just resetting the software end of that without sending a hardware reset, and it doesn't seem to reliably work. So I think my plan there is I would like the Ethernet bridge to just separately have its own watchdog timer, so that if it doesn't see both packets being successfully transmitted and received, then it'll just reset itself. And when it does reset itself, I would like it to be able to issue a hardware reset to that microcontroller and not just rely on the SWD signaling. So I think for that, I just want to add another GPIO pin from the Raspberry Pi to that board. So that and the just overall speed improvement of not resetting it each time are the big goals for things I want to improve before getting that experiment started. But there's a small detour. So before I even get that going, I wanted to run a small experiment now that I have both of these boards free. So this is the kind of backup PLC that I'm trying to extract the firmware from using the original voltage glitching experiment. This is the first one that I worked on, which I've since bricked somehow. And so I've been trying to work on it through the only available interface, which seems to be the SD card port. It seems to be stuck in some kind of bootloader where it's not initializing most of the peripherals. It doesn't initialize Ethernet. It does seem to initialize the LCD, but then only sends usually a blank screen to it. But then it does communicate over the SD card. Like, it seems to look to see if there's a card there, and if there is, to read the root directory. So that started me down this other path of building this little SD card emulator for kind of interactively root forcing bits of the file system. So this is the little tool that I've been working on for that called FlipsyFat. And so with that, now I've got this thing that when I plug it into the bricked PLC, it pretends to be an SD card that has this special file. What was it called? Hey, Tuco. I wrote down the file name over here. Oh yeah, upbm.bin. So that was our hard-earned file name. So far we know that there's this file name that if it's present on the SD card, when this thing is in crazy bricked bootloader mode, we don't really know what else it's doing. Then in that mode, it will respond by, if it sees this file, it'll actually try to read it. And the question now is that functionality unique to the bootloader, or is that something that exists in the kind of regular PLC also? So that might be a question we can ask or answer pretty quickly. First, I just want to do a control experiment to run the emulator on the bricked PLC and just watch it work correctly to make sure that's still working. And then we'll just try plugging this into that PLC and booting that up and just see what happens. I would expect it to look for potentially other files on the SD card. So, this thing usually uses the SD card for storing interpreted programs. I think there might be some functionality for automatically loading new configuration off of the SD card if that's detected. So I really wouldn't be surprised to see it looking for something, but it would be an interesting nugget of information if it does respond to this same file, which means that if we figure out what format that file is in, maybe there's a way to just push code onto any of these PLCs, even if they're not in this kind of weird bootloader mode. Oh, hey, just catching up on chat. Garrett in chat is asking if the bricked bootloader mode keeps SWD locked out. Well, actually I haven't checked. I don't see how it would have the opportunity to not also have SWD disabled, though. That's done by blowing a fuse in flash memory. So my assumption for what's been happening so far is that there's some software decision that's being made by the processor early on that either is directing it to a different code path where it's loading this file off the SD card, or is causing it to stop after looking at the SD card before going on to its normal thing. And so that's the either or that this experiment might tell us about. But All of that happens, I think, way after the processor would have had its debug interface disabled. I do have JTAG broken out on this board, so we could try that without too much fuss, but I would be really surprised if that would show us anything. Let's get that, VM going. I guess I want to run that on this machine. Equipment is a bit of a mess here too, because I'd like take a bunch of stuff out of this little makeshift rack that I have here to debug my CAD machine earlier in the week. And it's still kind of a mess afterwards, and I realized that my solution of like IKEA furniture with hardware piled in it is pretty bad, and I really need a real rack, so I ordered a real rack. It'll be here on Monday, I think. I already have the UPS, the shelves, and the power distribution unit that go with it. So that'll be really nice. That'll replace this little fire hazard over here and give me a better place to put the 6 or 7 machines that actually run this operation. Okay. Yeah, we already have this VM going. Let's have the power of HDMI. No, we don't quite need all of this stuff on the screen yet. Oh man, I need to... This mouse has different problems. I no longer have the wireless to fuss over, but I just have it set way too sensitive right now. Anyway, I can fuss with that later. I did at least glue magnets to it. Now I'm just trying to move this VM to the other monitor. Having that particular brand of UI fail where there's literally a 1 pixel wide region you have to find. Alright, so here's our VM. That will be powering the FPGA board here. And we need the amplifier. That will also be running the device under test board. Oh, that's really slow. Alright, I was just realizing in the last experiment I had the clock set to divide by 128. Oh yeah, Mikey in chat says, a shame the roof is so high. That many machines would keep the place quite warm in the winter. Well, yeah, there's also a lot of single pane glass. Like, this place is very drafty, so it takes a lot to keep this place warm in the winter. Usually I just end up having to... Actually, my favorite warmth solution currently is a little heater I can put under my feet. A little electric heater. Let's see, I think we want... I guess I might as well... This is like a work in progress experiment that I was working on to do the next step in the bootloader kind of file reversing experiment so that I could edit the contents of the file, but I guess we can use that here. So this is going to pretend to be an SD card, and it'll need a little more screen space to be usable. Oh, let's actually have a different layout for this. Okay. This is a bit of a mouthful, but Let me see if it works, and then I'll try to explain what it's doing. Oh, I have this on auto reset, which is why it's not. It keeps showing us the reset state, because it doesn't stay in the completed state very long. Let's turn that off. This is what might be an anti-pattern of coding these experiments, so that when it detects the last thing happening, it just goes ahead and sends a reset. I might want a way to have a delay there, just so that I don't forget about it, or at least a command line option. Reset. Okay, this is still in super slow mode. Let's have it be in less super slow mode. That seems better. Okay, so there I was just resetting the target. And so you can see for a while so the thing I'm mostly looking at are these numbers up here. Specifically this last read is, whoa, that's telling me in bytes when where the offset of the last read from within this particular file we care about on the SD card was. So it'll start out as all Fs, which is just what I set it during reset. But then the first time I get a read from inside this file, which happens to be this block 40db, so it calculates where in that file that read was. So in this case, this actually tells me it was reading the last block of the file, since I know in this case the file was 1000 bytes long, so 4096 bytes. So then if I subtract the page size from it, which is 200, I get E00. So this shows me that that read was the end of the file. I don't currently have a way of changing the size interactively, but if I did, you would also see that move. And then this line below it shows the order in which the block reads were made. So this is just a fixed size buffer where it's just writing down, since the last reset, here are all the block reads that happened. I can even imagine a variation of this tool where you could see the sequence of block reads and you could give it like a default file system to start with, but then you could just like arrow back and forth in that trace and make modifications to just those particular sectors as, interactively, just based on what you're seeing in the trace. So that might be something to do in the future as I evolve these tools a bit. Right now this is still pretty basic, and I just have kind of a hard-coded region that it's hex editing, which is this particular file. And so this buffer up here is just literally hex dumping the SD card emulator's chunk of SRAM in the FPGA. This is just the memory buffer that just happens to be whatever we sent back to the host last. So it's a kind of a confirmation, like you can edit the entire file down here in this hex editor, and then you'll see once it actually requests the part that you edited, you'll see that show up in there. So for example, if I scroll all the way down to the bottom of this file, it's a little bit slow. I don't have a lot of commands yet for like go to this address. Incidentally, it would be really cool to have, I don't know if this kind of thing exists yet, but it would be really nice to have just like a separate UI front end for a hex editor that I could just slap onto any chunk of memory that I have in an embedded system. And I'm wondering if maybe there are any hex editor apps that you could point at a memory mapped file and it would give you something like that. But anyway, so now I'm near the end of the file. If I hit reset now, you can see it takes a couple seconds and then nothing much happens. But if I were to start like filling this with Ds, for example, and then reset again a couple seconds later, now in that buffer you can see those Ds show up. So that just kind of confirms that here I edited the file and there the device requested it, and you can see exactly the block that it last read. And the only reason this is constant is that the device kind of gave up and now it's presumably busy waiting or sleeping or something. And then down here we have the normal stats there. So if I were to plug this in, so let's do another control perhaps, and oh, can I do that without it being a huge pain? I think I can. I'd like to plug this into just any other SD card reader and watch it get to a different point in this process. This isn't really necessary and it's a little annoying, but I like control experiments because they help you know what you're actually looking at. The only reason this is annoying is that this is using a different wiring harness that is harder to connect to a real SD card. Or a real SD card reader. But I've got this thing. And these two objects will do what we want. Oh no. Looks like some folks are having trouble with YouTube streaming still. If you're having trouble with YouTube streaming, you might want to try Twitch. This one's also being broadcast at twitch.tv/Senrio Labs. So that one, yeah, all the stuff I do on these Senrio projects goes to Twitch and to YouTube if you like redundancy. Alright, I think the safest thing to do here is just to ground myself. Oh, that's interesting. Axel in chat points out that there might be a way to do that kind of live hex editing stuff with Notepad++ and its hex editing plugin. That's interesting. Might look into that. There's probably a way to do it with Emacs. Oh, did I do something really smart and tape these together so that they would all be easy to plug in? That might have been awesome. Let's see, clock is white. Yeah, I think these just plug on right here. Okay, so now both of these are connected to the emulator, which is not really what I want, but now I'm just going to unplug this end. And now this is kind of a transmission line stub that I don't really want, but I'm going to see if I can get away with it. If not, I'm going to have to label these so that they're easier to plug back in and then unplug them. Because this thing is going to try to use my SD card at 50 megahertz, which might be annoying. Let's see if that gets in the way. If it does, I can always test this with a slower device. So let's get that experiment running on the FPGA again. Hello? Right, it would help if I used the correct keyboard. Also want this to be connected to the VM. How? That's better. Okay, well, not all of that fits on the screen, but you can see the important parts. So, last read and the block. So, I'm gonna try to plug this in. Okay, that's a lot more reads than the last thing. You can see it read the MBR like 5 times, and then started reading different parts of the file system. And this looks like the fat. Okay, well that's fine. Yeah, we got it. Okay, well that makes me happier. Let's try this with the other PLC then. Man, so much wind. Does anybody else hear that wind? Okay. So that is off. This can just, ooh, can it? There's a little bit of glue on there. This is like a little drawer that the SD card fits in. So it's like meant to be a removable thing. But then I also hacked this one into an adapter by soldering a bunch of headers to it with little wires. Okay, bit of a Rube Goldberg machine here. So for this to do anything, it needs its clock source. I could hook up this clock source, but I think it's easier just to turn this back on the way it usually runs. So let's do that. For that, I need the other computer because this is complicated for some reason. Mostly because of the completely arbitrary separation of which things run on the work laptop and which things run on the lab computer here. Okay, so this needs this VM. Restart the clock generator. Oh man, and so I keep thinking like, what's gonna be the last straw before I kind of redo the setup to be simpler and less annoying? Because right now the combination of the stuff on the Raspberry Pi and the stuff on the Chip Whisperer and the stuff on the iStick is getting a little old. And it would be nice to have one place to manage the experiment from. I think the stuff on the Raspberry Pi can be made pretty self-contained and not have to deal with the rest of the experiment state. But the stuff with the Chip Whisperer and the iStick is kind of annoying. So now I need to reset the FPGA on the iStick. Really? Are we having that again? Oh, it's so hard to type on that when it's not on a flat surface. Oh, was that not the problem to begin with? Was it just actually not plugged in? Oh, did it get grabbed by the VM, maybe? Man, that wind is loud. It did not get grabbed by the VM, but also this machine can't see it. Can I use this as a way of resetting the device? It is actually physically not easy to unplug it from the hub. That is annoying. I seem to remember last time I had this problem, I ended up having to reboot this computer. It is just not seeing this USB device. Blah. Okay, well fine. Might as well rip this Band-Aid off. Always a yak to shave. You can be sure of that. Well, I guess in other news, as we wait for this thing to reboot, oh, so yeah, I was enjoying this other alternative social network recently called Mastodon, which is basically seems to be like for people for people who like Twitter if they wanted, assuming they want it to be like more decentralized and harder to harass people with, hopefully. So it's an interesting project. Anyway, I was on there, and that helped remind me that like a lot of people, they were posting stuff about trans day of visibility, and it was kind of reminding me like, oh yeah, that's a thing. So, I mean, I generally am not too shy about it, but I figured it was worth explicitly stating that like I'm trans and I'm pretty open about it, and it's not something that you generally want to be like spreading around without people's explicit consent, but I also recognize that there's a lack of people out there that you can just like talk to about stuff. So it's good to have days like this sometimes. Which computer am I even logging into now? I don't think I care if this password's on the stream, but I also don't know where the cat is. Yeah, I don't know where Tuco's. So I've got the door open. I think Tuco might be hanging out in the hallway outside. I mean, not like the outdoors, but like in the warehouse here. He usually likes to hang out in the hallway and say hi to folks. And he's a very social cat, much more so than I am. So I do, remind me later, please. I do still need this VM. I just also need to have control of the other hardware. So I do probably have to unload the Kext now that I've rebooted. There we go, finally. Oh, interesting. Just catching up on chat slightly. Just a little off topic, but an interesting question about FPGAs. Not quite sure how to pronounce this name. Vega Roxas, I think, says, "Hey, I just ordered the FPGA I wanted to buy. I'm going to buy some more electronic stuff tomorrow in a shop in my area. For a first project, I wanted to make my own Game Boy flash cart. However, I just noticed that I have no RAM. Is there any other feasible method that's fast enough so the Game Boy actually works with the data I provide?" Well, yeah, so actually, there's a good suggestion from Electronoob about some Game Boy specific channels that might have better answers. But one thing that just comes to mind off the top of my head is that depending on the FPGA you might have enough block RAM for a really small Game Boy game. Because like remember, Tetris was only 32 kilobytes, and you can squeeze it smaller than that if you you could take it as a challenge. Like imagine if you had only a little bit of code that might fit in your FPGA block RAM, and then maybe you use the FPGA to algorithmically generate a bunch of graphics content that the Game Boy then treats as tile ROM. That could be interesting. I don't know. That's my kind of nerd snipe. Well done. So I think this is clocking again. I do still need to run this to reset the PLL, but actually it isn't clocking. Let's reset this. Yak stack would help if that was connected. This is why you need control experiments. There are always so many different ways something can break that you've got to make sure that you're finding exactly the right kind of breakage. Okay, now the blinking lights tell me that the clock is good. That's why the blinking lights exist. Okay, so now I can apply power and the PLC should boot normally. And let me do that first without the FPGA attached, just for, you know, a control for the control. Yo, dog, I heard you liked control experiments. All right, 12.5 volts. It looks like it's booting. Let's get a zoom in on that. Yes. So that is the PLC working as normally as it's going to in its present state. Let's power that off again. And run the emulator. I just need like 8 of these remote controls so I can just have one on every surface I might look for one on. Oh man, this mini USB feels super loose. I need to, and I don't know whether it's the connector or the jack. It's tempting to just replace the whole thing with a micro USB or with a full-size USB Type B. I still kind of regret putting a mini USB on the Fade Candy board, which was like my one commercial product with a mini USB on it. And it was mostly due to manufacturing constraints at the time. It was like one of those things that was just a factor of, you know, a product of the time it was made in. All right, so this is running. So now we're getting close to actually a result from this experiment, maybe. So that's plugged in now. So we should see it. So the results here at this point may be worth enumerating. So if this experiment is working at all, I would expect to see it at least reading the master boot record and enumerating the root directory. Then the result we're expecting to see is, does this thing care that we have this bmup.bin file present? And that, for that, we'll be able to look at the trace here and see, you know, does it stop after reading the root directory, or does it go on and actually look at the contents of the file? And I'm hoping this doesn't get us wedged in the bootloader, because that would be sad, but I think that's the only risk I can think of to doing this experiment, so let's try it. Whoa! Did you see that? I think it tried to read the file, and then it went back and reset and read the MBR again. Let's remove this and make sure our PLC is not bricked before we get too excited. Okay. That seems nice. Wow, that's a useful data point then. So, yeah, this might mean that we're not actually in a bootloader necessarily, but that we broke something and it's failing to initialize somewhere. Because the thing that's unexpected here is that the working PLC would show basically the same behavior up to this point. That's interesting. So, yeah, so it went and read that. So just looking at this this trace again. So this is the MBR 0. Then 3F is the root directory. No, that's the fat header. I think the way this works is that 3F is the fat header, because I think that's the beginning of the partition. And then BC is the root directory. 50 is the fat, where it actually looks to see which it's reading the cluster chain in order to figure out where the end of the file is, because it knows where the beginning of the file is from the root directory, but this is how it finds the end. And then this is the actual end of the file itself, the actual contents. But then it's going back and, I mean, this is, assuming I'm not breaking it by running this, like, I don't want to risk getting it stuck in this mode, but yeah, like what might be happening here, like it'd be really interesting to check out the timing of this on the scope, because like this might be exactly the same sequence of operations we're seeing on the bricked unit, and then like right here is where the bricked unit would be hanging, but then when we go into kind of normal firmware operation, it then just kind of mounts the file system a bunch of times in the course of its normal operation. The other thing is it's possible this is still a bootloader, and like this is it initializing the bootloader and reading that file and then giving up on that file and then running the regular application. And then the regular application has its own entirely separate SD card stack that then also needs to read the MBR and read the beginning of the partition. And then it just does so multiple times because it seems to have initialization code that's written like that. That is interesting. Yeah, so this read that you can see it kind of getting stuck on is the MBR. What was other numbers visible? All right, let's just let this run some more. I don't think this by itself is going to break anything. I think it's at least looking for a signature in that file that it isn't finding. Checking card. That was interesting. Oh, I guess I didn't have that on the... So there is a new step in the initialization that I hadn't noticed before. This is our reset button. That happens. So that would be consistent with this being a separate bootloader that also has its own LCD driver. I don't know. But it does certainly seem like the kind of wiping the screen section was probably... Like, I guess I don't know why we're not seeing that checking card screen on... on the bricked unit. I guess that could be completely unrelated to the like update, bm.bin that we're looking at. That could just be the application proper doing something else after it reads the card. Oh, sorry about that. Electronoob in the chat was saying that they wish my terminal wouldn't refresh when there's no new data. Yeah, the flickering's kind of annoying. This is mostly me not having access to ncurses when writing terminal code on the microcontroller, which I guess I could compile that. So it doesn't like diff the screens like ncurses would, it just draws it again. And terminals usually can buffer that stuff, but when it gets long enough, there's usually some threshold they cross over. I thought I heard Tuco upstairs just now. Oh, there he is. Hey, cat. Hey, boy. All right, Tuco. Oh. That always amuses me when I see it. That's my fake SD card. Oh man. This is just interesting. Like, this is not quite what I was expecting, but that means that now it's exciting to think of, like, where am I going to go next with this? Let me reset this. One thing that's kind of annoying right now is that my trace on the emulator is not being reset at the same time as the actual device. But if I reset that manually, I can see that it's not growing. Let me try to put that on the screen in such a way that it's not annoying. Hey, Tuco. Welcome back, Tiger. Oh. Are you going to sit on that pile of paper, Tuco? Oh yeah, just for the there's a good question in chat. Oh, I'm gonna struggle with this name too. Twile Dawnite, I think, asked about if there's any info about my streaming setup. And yeah, Sodium responded in chat with something I'm going to say here too, that I've got some info if you go to my GitHub. It's github.com/scanlime/broadcasting. That's basically all the scripts and stuff that I use for this. And the README explains roughly what the setup is. It's always a little bit out of date, but it's the best thing I've got. And yeah, sometimes I'll explain it on stream. I really should do a separate video. It's just it also kind of keeps changing. Oh, Tuco is just not standing still. Pardon me as I struggle with a different mouse than usual. Maybe I can put this over here. Okay, well the thing I care most about is I'm going to be using this to reset the trace, and then I'm going to be pushing a button over here to reset the PLC, and then it'll start filling the trace. So all that stuff before happened before we even saw starting on the screen. And that time we didn't see the checking card message. Same thing there. Let's clear that again and see if this sees the card for just normal operations in the current state. Are we running? This UI is kind of slow when it's underclocked. Let's reset this too. I guess I have to stop. Oh, maybe that will change the startup mode if it doesn't have the PLC program to jump right into. Because the card menu wasn't there before, was it? Yeah, card menu only shows up when the program is stopped. So we can save the program. Good luck with that. Yeah. Load. Huh. I wonder what it means by that. Because it's only looking at the file system. This might be... I mean, it's possible that the application itself is a lot pickier about file systems than their bootloader is. Let's see what it does when I reboot it now. Clear that list manually. Yeah, same thing. I was seeing a different thing before. I was seeing that checking card screen. I'm just doing this a few times to see if it's kind of random. That's weird. Well, in that case, this is still a little bit mysterious, but it does tell me that whatever debugging I do with the bricked unit on the SD card, and I should be doing whatever I can on the bricked unit because I can, you know, it's always good to divert the risks to a unit that's already got problems if I can get away with it. Oh, that's a great idea from chat. Oops. There we go, unplugging USB mini cables. But you'll see why it's important. It's probably a little warm for this today, but this is my shark cat. Oh, and this is my cat. Okay, all right, well, I guess where this leaves me is I still want to do these, so this whole thing was kind of a diversion in between voltage glitching experiments on this one. This has been a useful data point, though. Like, this tells me that whatever work I do on this other bricked PLC is probably a lot more useful than I thought it was going to be. And then it's maybe less bricked than I thought. This also, yeah, I guess I'm just thinking about, like, on this project, the next thing there is, where is the next side channel? Since I'm at the point right now where I know, I was able to brute force the file name that it was looking for, by using a timing side channel, by looking at how long it took to evaluate whether a particular root directory block was interesting before asking for the next one. But now I'm in a state where it looks like the decision it makes is, do I continue on and fail to run the application, or do I enter some kind of failure or panic state because I don't see the contents I'm looking for in this file? And I don't know how to differentiate those two failures yet. You can kind of see the difference in the power trace, but even, like, I've only looked at that on my slower oscope yet. I haven't checked it out on the nice oscope, so it might be obvious on there, but what I really want is to find something that's easy to automate. So either, maybe there's a DC current change that I can look for. Maybe there's, some I/O that goes into a tri-state status, something like that I could look for. But it's basically trying to think of, well, if I was writing the error path in this code, what might that be likely to do as a side effect? Is it going to be disabling interrupts? Is it going to be entering a tight loop? Is it going to be shutting off peripherals? Is it going to be tri-stating I/Os? Is it going to be doing none of the above? So that's kind of the next question to answer on this one is, where is my oracle that helps me determine which file contents are interesting to this bootloader? Since right now I don't have a good one. Anyway, it might still be good to put that aside, and I guess the decision next is, like, what do I want to focus the good equipment on? Like, what do I want to have the scope busy scoping on? And I think it is still useful to get this voltage glitching experiment going again, hopefully faster, and then let that go in the background while I work on this problem, the sub-problem of finding the next side channel for this one. So, all right, well, I think that's the strategy. I think that means I take my data point, I enjoy it in its full deliciousness, but then I put this rig aside, and hey, cat. And I go back to improvements to this old contraption here. There's a very glue-covered SD card here. Oh man, it's a chair and it has paper. Two of Tuco's favorite things. You don't need that indoors, Tuke. Oh yeah. Yeah, I got this shark hat. Where was it? It was the Alternative Press Expo in SF many years ago. Well, not that many, I guess, but there was like a friend of a friend there who was selling these. I'm terrible with names, but I think her name was Isolde. And yeah, they were really nice. She was selling a bunch of good animal hats, and I got this one because it was my favorite. Oh, Mr. Antbox is asking in chat if the backlight on the LCD turned off a few minutes ago. It did because I unplugged it, but good eye. The power supply over there is a little off camera. All right. Well, actually, I think I need a brief restroom break. So I will leave you with some full screen cat in the meantime, and I will be right back. Full screen cat and wind. Oh, every time I leave you guys with the cat, he leaves. Duke, what's wrong with your paper? His interests change so easily from pile of paper to human near the bathroom and the food. All right, well, let's just focus on something relatively straightforward first. And let's wire the Raspberry Pi up to this board's reset and try to automate some of that. I think for that I want some schematics. Hey, Tuco. Are you coming back, little dude? Oh, this is also a little off topic, but I was curious if anybody had suggestions for conferences, for people who don't like conferences. 'Cause, you know, it's one of those things where I like publishing work and putting it out there, but I'm really not a social person and I don't really get a lot out of conferences. So I don't know, we were talking about maybe going to Black Hat and looking at the CFP, and I don't know, just really didn't want to go to Black Hat. I mean, I guess it still might happen, but it just doesn't seem like my kind of conference, you know? Hey, Tuco. Oh, now I have to remember what this board is called. Actually, I bet Google knows. Let's make that less giant. This mouse is definitely way too sensitive at the moment. Hey, Chico, are you inspecting the audio gear? You better be careful with those wires, little dude. I am looking forward to that being in a rack with a front that closes so I don't have Tuco messing with all the audio levels. That is not the one I want. Yeah, this is the TM, this one. Yes. I just want to know where I can get reset easily. D1, pin 5. Oh. Do I have to go all the way to that header? Well, I've already got header soldered in there. I guess I might as well use that. Sure. And I guess I could either, I'm using OpenOCD to handle the single wire debug stuff, or the serial wire debug, but I'm wondering if it can also do the reset for me, because right now I'm not giving it a reset pin, but I should see if it supports that, because that might be really convenient. So what is this? This is regular OpenOCD. Yeah, this is the driver we're looking for, BCM 2835 GPIO. So this is the driver we're already using. I just want to look to see what it supports, to see if I can have it do the reset. Looks like it. So I think I just need to make sure that I set the right reset pin in the config file, and then there might be different reset modes that OpenOCD works in. So I'll want to make sure I'm in the right, that I have that set up right. I might just also scope out the reset pin and reset OpenOCD and see if that does what I expect. And then just wrap a software watchdog timer around this whole thing so that it resets if I don't have packets going back and forth. That kind of works. Okay, it's too warm for the shark hat. All right, how is any of this configured? So, this is my OpenOCD config. Does this maybe already have a reset pin set that I'm not using? I don't remember what the difference is between T reset and S reset. Tap reset. That just resets the JTAG tap, the debug interface. I don't know why we'd want a signal for that. So this is the signal we care about, S reset. So okay. I don't know if I want that to be push-pull, but oh, I guess this gives an explanation. They're like, it may be advisable to use push-pull drivers if you have a really weak reset pull-up. I guess I buy that. I'm not going to worry too much about that right now. Anyway, this might already be configured right. Let's just check out pin. I think these are the Broadcom pin numbers, not the Raspberry Pi pin numbers. No. That's what I wanted. BCM pin 18. So let's see if we already see a pin out there. Probe. Oh, is it want for more grounds? Let's get that on the screen. Using the ridiculously sensitive mouse. All right. So there's our reset. I assume it's floating low. Let's try giving it a weak pull-up. That would involve bringing this out to the breadboard. Oh. Let's use these. All right, here's a pretty arbitrary high-value resistor. In this case, it's 68K. Just going to pull it up so we can watch it respond to that. Of course, for that, I would need some nearby 3.3 volts. I would like to get 3.3 volts from something that's actually powered on, maybe. I think something on one of these X headers would be easy to grab. 6, 7, 8, or 9, it says. It'd be nice if I could zoom in and look at the signals on these nets. No, but where's the pinout for those? I think I'm going to have to look up the pinout for their booster pack thing if I want to know what that actually is. Does this not have the... Oh, is this what I want? This is familiar. I think this is what I was looking at before to get these pinouts. Alright, X6 pin 1. Can I do that? Yes. A little forest of resistors and leads. Alright. Okay, the scope is connected to that pin 18 again. Yay, and if I apply the pull-up, you can see I get a nice noisy 3.3 volts while I'm holding it. Great. So let's see if running OpenOCD gives me any edges on here. All right. Oh, where's that voltage coming from, actually? I didn't realize that was so low before. Do I have like a weak pull down on this somewhere? Because that's definitely a 3.3 volt rail. And come on. There's my volt point something. Well, I guess that's just its push-pull driver pulling the line high, which is not ideal, but I don't think it'll actually cause a problem. Anyway, I think right now I just want the OpenOCD command line so I can see if I can manually reset. I guess I can break into GDB from my proxy script. So this is trying to run normally, not getting a link. I just Control C a bunch. Sometimes I can get it to give me a GDB prompt instead of exiting entirely. There we go. How do I issue OpenOCD commands? I thought there was something like a monitor. Yeah. That's better. Oh, you get some little glimpses of noise on the scope every so often. Yeah, let's see how to issue other kinds of reset, because I think that's the issue here. S reset. That doesn't seem right. Oh, maybe it does. So I think that means we have no T reset and we have a separate S reset, which may be right. Hit reset. Ah. This is like a bunch of stuff from like the last several commands that I think piled up. Oh, or maybe it's just searching. I think it's just searching the help for everything that has reset in it. Weird. Let's just try reset config S reset. S reset only. Ah! That was the pulse I wanted. So that was from monitor reset config, S reset only, and then monitor reset. That's what I want to do. So let's also actually connect that to the other board instead of just this little test fixture. I can just go right alongside the single or serial wire debug stuff here. Attached, a little difficult to scope, but what? Yeah, let's put these into our script so they actually run. Monitor, reset config, S reset only, and then monitor reset. Really don't want tabs in here. Thank you. No tabs. I might have been off the scope. I might have missed it, but it also might have just not happened. Stop that. Hey, Tuco. This is not the right order to have any of this in, is it? Oh, I forgot how this part works. Let's just see if we're getting to this point. Something is not as I expect it to be here. It's weird. Am I running multiple instances of this or something? Ah. I have some nice unkillable GDBs now. Well, used to. Oh, so, I mean, I guess I'm just not seeing the reset that I was expecting. I mean, so exiting that script should just drop me back at the GDB command line. Um, oh, did I just get this wrong? Did I not reset config? Yeah. That's better. Let's see if the rest of that works. Always about remembering the commands wrong. Oh, now I get 2 of those. Okay. Maybe that is implied during the run operation? Oh, I might need to take this. Right back. Hello? Yes. Oh, yeah, so there's a callback on the 62nd Street side. That took longer than expected. If anybody's still here, sorry about that. Yeah, it was a delivery. And then some heavy packages. This building my shop is in really confuses all the delivery drivers. Just a couple of random Amazon packages that could be anything. And then one kind of odd one. Speaking of trans day of visibility, one of these packages has a name on it I haven't used in ages. I'm wondering if it was just some default associated with my PayPal account or something. Hey, Tico. Oh, are we back, Tico? Yeah, anyway. Where were we? Getting the reset signal going. Wondering why I have unkillable GB processes all the time. Always struggling to keep the cat on the camera. Cat noise is coming from over there, but it's not quite clear what he's into. All right. I would like to have a nice watchdog that keeps track of these processes and restarts them if necessary. For now, I'm doing that manually, but that is coming up quite soon. So, reset is on the scope. I want to reset pulse, but then it doesn't come back up really. Oh, or does it? No, I don't think that worked. I think we need to be telling OpenOCD about the different type of reset pulse sooner. OpenCOD. Let's try that. Those GDB processes. That time it was fine. One reset pulse comes back up saying link is down, but I should be able to give it a link just by powering on the other end here. Okay, TX. Like, it might literally be like a ping that I run, and if it doesn't respond to pings for a while, then I reset everything. have that, if I were to see, that seems good so far. This might be reliable. Tuco, you want to go back outside? You were just out there waiting for me to come back from the mailroom. That time it didn't come back. So would my watchdog just kill that again, and we would end up trying the whole thing over again? No, that's got the same problem. Oh, interesting. Good feedback from John in chat, who says that this current view on my open broadcaster setup seems jittery compared to the other ones. That's interesting. I wonder if it is different when I have the preview locked. I don't know why that would be. Yeah, it's weird. It doesn't seem to be CPU limited. It's plenty of CPU free here. It doesn't seem to be dropping frames, but oh well. Well, maybe I need to take a slight break from this and maybe open some of those packages, just because, you know, why not? That's always a fun thing to do on stream when I don't know what else to do. I'm really curious about this one, since, I don't know, it's not like an Amazon package, and comes here from Nicholas Gussie, and it has, the thing that was weird about it is it was just like addressed to a name that I haven't used in a long time, which is kind of weird. Yeah, this is what I get for not updating my PayPal account. I made a donation to, you know, AGDQ, the speedrunning thing, or, you know, it's games done quick. Yeah, and so I won this. I won the NES Classic. So I'm actually pretty jazzed about both playing this and potentially hacking with it, but I guess the slightly sketchy mailing label was because they used my PayPal info, which I haven't had a way to update. But yeah, oh, that's cool. I feel much better. I was like, is that like hate mail or something? No, it's a prize. It's not hate mail. It's just an unfortunate labeling for a prize. Cool. Well, the other packages are probably less interesting. That's not even a package, that's just a piece of cardboard. Oh, cool. Kyle in chat says that those Nintendos are super fun to hack. Yeah, I've seen a little bit of it. Apparently the controller ports are USB. Oh, okay. This was another attempt at having a keyboard for this controlling stuff on the stream and elsewhere. To give this a try. I think I managed to get my setup so that I need a keyboard at this desk other than the one I'm actually working on pretty rarely, but input devices are a challenge when I have this many computers that don't otherwise want to use compatible input situations. Oh, pink. I think this is my solution for printing more of these. So I've got these bootleg Dave CAD notes. And I think so far my favorite way to print these is with a pink stamp pad. But I think this stuff might actually be even better. This is block printing ink, which is the proper stuff for the process I'm using. But yeah, that's basically what I'm making. It's also another side project, but last one. Oh, power connectors. Yeah, I was low on these. I needed some more XT60 connectors. Anyway, I hope that was fun. So now we still have this. Are we missing video? How did that happen? There we go. I just had to turn it off and then back on a couple of times. So I guess what I'm seeing is that this is kind of successful, but what I'm looking for is like a reliability safety net for these long experiments so that this part is not the problem that keeps it from working all day. And if this just sometimes fails to restart, then that's not really doing me any favors. There's so many ways that you could dig into this. Like, why do we have unkillable GDB processes? Like, what is it actually doing? Should I attach GDB to GDB and find out? Can we do that? Oh. Do we only have one thread? Well, it's waiting on something, but I don't think we have GDB compiled with symbols. So that's probably not going to be amazing. You can kind of see where GDB was hanging out, like waiting for stuff from the remote end. This just looks like GDB has some implementation flaw such that you can't kill it with a signal while it's waiting on the other, while it's waiting on its debug stub to communicate. Well, that time at least I could kill it with a signal. Oh, nice. Speaking of mail, I guess a lot of people like the mail. It is a kind of nice surprise. Like, here's this pile of problems that we've very carefully set aside for ourselves, but then the mail is like, here's a bunch of brand new problems. Oh, and then the one that you didn't see, which was just spewing cardboard fragments, was just cat litter for Tuco, which is really heavy, and the box was disintegrating as I was dragging it through the hallway. But Alex was saying, in related to mail, once I received elaborate blueprints for a large bear costume in a poorly labeled tube, freaked me out until I remembered it was an extra for subbing to tested.com. Yeah. Yeah, it's always the ones where it's like, why would they be sending it here? Or like, why would anyone be using this? And like those kinds of things. And it's like, oh, this is out of the ordinary, but not for any sinister reason. Well, I'm just wondering, like, at what level to implement the watchdog at. I kind of like the idea of like just issuing a ping from a separate process, or watching the counters on the tap 0 interface, making sure that we get both RX and TX packets. See, but like, why is this failing? This shouldn't even be failing now. It's just, here, I'm transmitting some stuff. Can I reset the device? Not the one I'm transmitting through, but the one I'm talking to. Now, if I start the proxy up again, then that ping goes again. So, oh, that's a good suggestion from Kyle, who says, I'd consider catting proc PID/stack for an unkillable process, and that might give some hints as to what the kernel might be doing on the process's behalf. That's a good idea. Oh, and then also a question about, did I get Vivado on Ubuntu to work? So I still have not tried Vivado. I don't have any of the newer hardware that works with Vivado, so I've still been using ISE. And so far, my best distro choice seems to be CentOS, because it's like relatively maintained, but still compatible enough with what they're expecting. But yeah. Anyway, now I'm just back to the stage of the problem where, like, there are a million ways of doing the next step, but can I do this with the fewest wheels reinvented? I mean, I kind of almost want the beginning of this script to start with, like, killing all other instances of GDB and OpenOCD, but that would be a really nasty thing for just a random script to do, so I should probably put it outside that layer. This is behaving super squirrely. Like, what I'm looking for is a command that I can run that reliably restarts this thing. This is still only transmitting. See, and that's all the transmit fluff that we get from bringing the tap 0 interface online, but we're not actually receiving anything. Now we're getting the pings back. But I mean, as long as we have something that eventually converges, it would work for these long-running experiments. I mean, I guess what I'm thinking of is something that if it just doesn't receive pings in a certain amount of time, then it, you know, turns this over, lets it restart. I'm just curious what other people have done for this, because I know I could probably just write a wrapper in some arbitrary language, but I'm curious. Oh no, I don't want to be in, like, IT land. I want to be in, like, Damon. See, this is probably also just going to turn up results for supervisor D, which is potentially useful, but I don't think it can actually do exactly what I'm looking for here. I mean, I'm using Supervisor D elsewhere. It would be potentially nice to just get this Raspberry Pi running this under Supervisor D. I don't know what, I don't know if it has like a way of plugging like liveness determination. I'm curious if it does. I mean, I like using this program partly because it's just easy to take stuff that wasn't really written to be a background process and to run it semi-reliably. Health checks. That seems maybe like what I want. Yeah, I mean, this kind of thing might work. It's maybe a little bit intense for what I want, but if it's easy to set up, it's fine. Oh yeah, here's... By ping, they mean an HTTP request to the /ping resource. Sure. I would like to avoid making this too sensitive to problems in the device under test, so if it's failing to ping because that device is crashed, I don't want this to just be endlessly resetting. But... Oh yeah, there's also some good discussion in chat about FPGA IDEs. Can I get any of this on screen? I'd like to avoid making this too nope, nope. Yeah, so a little bit of discussion about the Vivado and Xilinx ISE tools. And yeah, I have no experience with Vivado personally because it only works with the newer Xilinx FPGAs that I haven't actually tried yet. I've used some really ancient versions of ISE, and I can tell it's improved a lot, but it's still pretty bad. But yeah, my current favorite flow is using... Yeah, I really like MySock and MyGen, and they, they have wrappers around all the other tool sets, so you don't need to use as much like toolchain specific knowledge to get your thing to build. Oh, that seems useful. Yeah, let's see if this supervisor add-on stuff, whatever this was called, was actually packaged into Raspbian yet. Oh, there's the cat. is having laser focus for the cat? You know, I wonder if I don't even need this. Maybe this event listener framework and supervisor actually does what I need. So, tick 60. Could this just be a cron job? Okay, I think I'm getting a little bit too hungry / cranky at this process. So just to take a step back. So for this whole contraption, there's the process of making the network connection reliable. For that, you know, there is still one option, perhaps. I've been trying to avoid it because this involves a lot of backtracking, but it might be interesting to try getting a voltage glitching setup working for this thing that is not underclocked. That would avoid the network proxy, which is almost reliable at this point, but is still kind of annoying. The one thing that has changed that would maybe make this more feasible is I got some eval boards with really fast MOSFET drivers in, so that might actually be capable of generating a glitch that would work out well even at full speed. I also have a faster scope now than when I started, so that might work out. And that would save some steps for sure and make the experiment less complicated. It would also make it faster. I think that just saving resets is probably going to make it faster enough, though. Oh man, got some good FPGA horror stories in here. Xilinx tickle variant. Tuka, what did you do? Oh, Wild Mini asks what my 3D printer is doing right now. It is making some boxes, and the one in the back is making another toy bolt. Some stuff that's useful around here, and a thing that I will probably give to a friend. Hey, Tuco. All right. Supervisor D events. Well, as much as I'm sure folks would love to just watch me read documentation for open source projects, yeah, I feel like we're probably reaching the end of the stuff that's actually interesting in this stream. Well, we definitely found some interesting new data with that tidbit that the SD card file we're interested in is being looked at on the non-bricked unit also. That's super useful. But yeah, I think my course of action here is mostly to just do some more kind of boring fussing on this to get it running reliably, and then leave it running for a while on a slower glitching experiment. And then while that's working, I can do some work on so on the kind of SD card, file emulation front. I think the next big thing that I need there is to look for another side channel. So either a more reliable power side channel that I have right now, maybe even looking at like DC current consumption, or an I/O that changes state into tri-state, perhaps. Maybe some on-chip peripheral that changes state. That's kind of the area I'm thinking to look in next. Oh, Alfie is wondering if I'll have another late night stream about the cat camera. I might have time. I have some plans this weekend that might make that a little bit hard. And so I'm probably not going to be able to stream tonight, but I might be able to do some tomorrow or Sunday, depending on how things go. But yeah, I'm excited about that project too. As always, I have too many projects going, but if you want to keep up with the kind of glitching and hardware reverse engineering related stuff, then I have Senrio Labs on Twitter and on Twitch, and for all the other miscellaneous stuff, there's scanlime. So I think that's pretty much it for today's hacking/entertainment here. A little bit of cat cleaning himself to end the stream. Gotta keep the cat tidy. Oh yeah, Alfie says that they're really enjoying the cat camera project. Yeah, I am too. That one's fun. If I didn't really have to worry about any obligations or keeping projects going, then I would probably just spend all my time working on that right now. But I do tend to want to just dig into one project. So yeah, I've been excited about that one. Since then we'll have. So for anyone who hasn't heard about that project, I'm basically designing a flying but not quadcopter robot moving around on cords that can point a camera at my adorable cat here under local and internet control. I think everybody's looking forward to that one. And I'm hoping I can segue that into a way of giving him his own kind of close to continuous cat feed. I'm still thinking about how the controls for that would work, since I would like to have some privacy in my shop still, but maybe controls that I can use to either make it like a free-for-all or restrict the camera to certain parts of the shop, or I'm imagining like even a mode where it could like pixelate everything except for the cat, but that's probably a little extreme. I don't think I would need that. It's mostly just because this is both my shop and my home, and as much as I enjoy inviting the internet into my home, it's something that is good to have control over. All right, well, back to getting a bite to eat probably, and doing some of the more boring and less interesting parts of the day job. But happy hacking, everyone, and I'll be seeing you all on the other parts of the internet. Hope you all enjoy the little tiger as much as I do. Peter in chat is saying, a quadcopter with internet access, what can go wrong? Well, it's not going to be as bad as that, because it won't actually be a quadcopter. It'll be on wires. So I have really high ceilings here, and the robot will be pulled around on cables by winches in the corners of the room. So, it will be still something that I have to have some safety considerations in making, but it'll be a lot easier to make reliable and safe than a quadcopter, I think. All right. I'll see you all later. Happy hacking.